All right, finally something that's worthy of our talentedness and giftedness, right? Okay, so we are going to set up two expressions. We're going to set up a sum of the forces in the y direction, right? And we're also going to set up a torque expression, right? Remember, torque is RF sine of theta. Okay, but in this problem, the force is either straight up or straight down, so it's at right angles to this level beam, right? And so the sine of 90 is 1, so we don't need to worry about that, okay? Um, and so we have these forces. They could be up or they could be down. That's what these little ambiguous arrows are. I think we can all agree, though, that F2 necessarily must be up, right? So my first thing is I'm going to guess that F2 is indeed up, okay? The force of gravity is going to act on this beam, and that's going to be down, right? The force of gravity is going to act on this box, and that's going to be down, okay? And then this guy is going to act either up or down, right? Now, if I'm torquing about this point, which is what I'm going to do because I want that to drop out of there, let's just set this thing up, right? Torque is, remember, clockwise is positive, right? And anti-clockwise is negative, okay? So this guy is acting at 0, so I'm going to go 0 times F1. Let's not argue about whether that's positive or negative, clockwise or anti-clockwise, right? Then I've got minus 4 times F2, right? Because this guy is tending to pivot around that point anti-clockwise, right? And then we've got plus, let's see, where is this guy? This is 18. It's 9 meters long, right? Okay, so the center would be at 4.5. So this is 4.5, right? Times 18 times 9.81. Okay. So 4.5. This thing's at 4.5 because that's half of 9, right? It's a uniform beam, right? Okay. And then we've got this guy here is at 5.5, right? So 5.5, right, times 12 times 9.81, right? And then that's got to equal 0. So we've got anti-clockwise torque, clockwise torque, clockwise torque. So the signs here are whether they spin it clockwise or anti-clockwise. This is anti-clockwise around this point, right? Clockwise, clockwise, right? This is at 4.5 meters because that's at the center of the beam. We always say that the gravity acts at the center of the beam. This is 5.5 meters because that's what they tell us, right? And I think we're set. And this one is solvable, right? So now we can solve for F2. Okay, F2 is equal to, let's do it. Okay, 4.5 times 18 times 9.81 plus 5.5 times 12 times 9.81. Okay, I think I get that answer and I just divide by 4. Let's hope that's how you do it. All right, so I get 360.5157. Okay, so that's what F2 is, which is apparently what we got there, right? And then if we do our y direction, right? Remember, y is just forces, so we don't need to look at where they're applied. Just simply, all the forces up have to equal all the forces down, or they have to add to 0 if we make the forces down negative, right? So I'm going to say F1 plus F2 minus 18 times 9.81 minus 12 times 9.81. Literally just what all these forces are. I'm guessing, by the way, that F1 is positive. I know that F2 is positive because I just got it, right? And now we're all set. That equals 0. And of course, for F2, I'm going to plug in 360.5157, right? Okay, so F1, if we solve this for F1, I'm going to go 18 times 9.81 plus 12 times 9.1. Okay, minus the answer I just got. And I get that F1, scandal of the day, right, is negative 66.2175 newtons. Okay. And that's often the case. If you got two forces like that, if you think about it, if this was a real pivot point, you let go of this, everything's to the right of this, so this thing would tend to fall that way if there wasn't a downward force acting on that. Okay. And so, yeah. So basically the torque expression, this is the way these things play out. The torque expression is solvable. Then you whatever force you solve for in the torque expression, you tend to plug into the other equations. Now there is nothing happening in the x direction here. All these forces are up and down, and so the x direction is nothing. There are no forces x, but there is in the y direction, right? The reason why the forces in the y direction don't have anything multiplied by them is, like here we did 4.5 and 4 and 5.5, is that they're not torque, they're just force. We just simply add the forces in the x and the y, and they add to 0. All right, I hope that helps.